Hello, thank you for watching this video. I'm Dr. Melina Vidoni and I'm presenting my work titled Evaluating Unit Testing Practices in R Packages. This work explores testing technical depth in R programming. This was chosen due to the differences so far when compared to object-oriented testing, the need to understand how testing is approached, and what challenges developers face. So testing technical depth has been thoroughly explored before. Research has focused mostly on object-oriented programming. Therefore, this work aimed to investigate how or if our packages are well tested or not, what plausible test smells can be identified, and how developers perceive unit testing in this very specific domain. To do that, I conducted a mixed methods investigation. First, about 400 packages were mined from GitHub using the advanced search feature and an R script. Further screening steps ensured that the inclusion and exclusion criteria were met. The second screening was automated as it required running the packages cover and tested to determine coverage and failing test suits. Overall, I recorded 177 suitable test repositories. Contain a file called description that states the developer's email addresses. This file is public. Therefore, these files were mined to obtain the addresses. Developers were contacted by email and invited to complete an online anonymous survey. It had a 19.4% of response rate. Now, in terms of findings, the first analysis checked the relevant lines, those that are not curly brackets, empty lines, and so on, and determined that only 43% are tested. Less than half of the code is being tested. Now, focusing on the untested relevant lines of code, or URLs, I took a statistically significant sample and manually analyzed them in categories: plots, returns and stops, variables, logs, loops, online operations like downloading something, wrangling, and alternative paths. Slightly more than half of the lines belong to internal private functions, and the worst tested groups are alternatives, accounting for a third of the URLs. Another sample was taken to classify the messages written in the asserts. About 40% are clear in terms of language semantics, but 45% are very challenging to read. Since this was analyzed by a single person, the analysis was run twice and then the differences were matched. Regarding how test files are organized, an automated check found that most of the packages have about 2 to 5.5 test files, regardless of the size of the code. Most commonly, there are 3 to 5 test methods per file, because if the 4 asserts are in the same test and the first one fails, then the others are not executed. This way, it is possible that test suits are not run in their entirety. In terms of the tools, TestAd has no way of automating the initialization of data through methods such as say units before all or before each. Moreover, in terms of asserts, 80% of the asserts detected are custom defined, and some of the asserts provided by TestAd were not found in any of the studied packages. Another subsample was taken to classify the asserts as common, edge, or dummy. Only 3% were determined to be manual, and all of them were evaluating plots. However, about 82.5% of the asserts evaluate common cases, leaving most exceptional paths untested. Now, regarding the survey, most participants are very experienced, with almost a third having more than 10 years of programming experience in R, and another third having between 5 to 10 published R packages. In terms of challenges, and regardless of their programming experience, about 60% still say that their lack of testing experience was a serious issue to them, and that the provided tools have very poor documentation. Even more, almost 10% still face a steep learning curve for testing, which is problematic considering their experience. Finally, about 58% of the participants said that even when their tests were all passing with colors, they still find bugs in their code. To summarize, these findings were matched with known definitions and examples of test smells. Overall, the most common smells are inadequate unit tests, not all paths are tested, and few exceptional cases are covered, obscure unit tests due to unclear assert messages and the distribution of tests and asserts, as well as improper asserts. This also leads to limited text execution. There were packages filtered with only manual testing, and improper test design due to all of the above. Furthermore, inexperienced testers is a clear problem outlined by the developers, which is quite relevant considering how experienced the respondents were. Overall, the unit testing practices so far cannot be considered comprehensive or high quality, and several smells were identified. We should work in improving the tools, their functionalities, and documentation in order to assist the developers. This work will continue by analyzing other types of debt in this domain and exploring test-related concepts such as coverage, testing of private methods because of a triple colon operator in R, and how to improve existing unit testing tools. Thank you kindly for listening.
Hello, everyone. I'm Leonardo Mariani, and I will share this session about testing third-party software. I hope you enjoyed the first presentation. Unfortunately, the author could not join us for this Q&A session, so we have some minutes for a short break. However, stay tuned because the next paper presentation will be soon played in almost 9 minutes from now, and we have the authors online for the Q&A. So I think we can close this Q&A session and talk to you later for the next Q&A session with the authors.